it is not always the case that you have your instruction sequence from just step 1 to step 2, or have it straight all the way from step 1 to the last end where you have to stop. Sometimes there are certain decisions that we need to take into consideration. Okay, that these, depending on the output of these decisions that we want to make, it could actually change the flow of the sequence or direct us to a different path. A conditional instruction or statement, also called a decision instruction, a branch or decision statement, is one in which a decision is made and the logic flow can follow different paths depending on the answer. So you can call it decision, conditionals, or branch instruction. Let's look at how you can represent this in pseudocode. In pseudocode, you will have it represented this way. If such and such, then do this and that. Otherwise, do something else. If this, if such and such, then do this and that. Otherwise, do something else. So I'm going to put my condition in there. If there is food at home, then stay and eat. Otherwise, go out and get the food. This would be a representation of the flowchart. So this shows you where the next instruction is coming from. It's pointing to the diamond. Remember, we use a diamond to represent the decision. So here you have such and such. If it is yes, then you do this and that. Remember, we use the rectangle to denote process. If this decision is no, then we do something else. Now let's look at an algorithm I prepared that determines whether a number is even or odd. So starting this algorithm, this is where we start. Okay, we use the over to denote the start, and then the parallelogram to denote an input or an output. So we start, we input x, and then we process this. R equals to x modulo 2. So the result is being given to R. We make a decision. If R equals to 0, we ask this question. If R equals to 0, see that there is a question mark here. If the result is true, then we say x is even, and then we continue to display the result, and then we end the algorithm. We come back to the decision when it is false. If it is false, notice how there is a different path that we are going to follow. If it is false, we say that x is odd, and then we display the result, and then we end. Now let's look at a pseudocode representation of this same algorithm. First of all, we start, we input x. If r equals to x mod 2. If r equals to 0, then x is even. Then you move all the way to display the result, and then we end. Else, this else means if r is not equal to 0, then we say x is odd. We end the if statement, we display the result, and then we are done. End. Apart from the decisions we make within an algorithm, sometimes you need to repeat certain steps of instruction until you attain certain result. We term this in computer program or algorithm concept as looping or jump statement. This is because you may meet a statement that will tell you to jump in and go back to a previous statement and execute it again until a certain condition is met. Now, as and when you move back to that particular statement until you get that result, we see you repeating series of sequence, and we call this looping or jumping an instruction. Instead of probably going back to the previous instruction, it could even tell you jump to maybe step 3 or jump to even step 4, depending on what you get. Let's see how we can represent this in pseudocode. So you have a step, item 3. You perform series of steps here, and then you move to the next step, and it tells you jump to item 3. And then you go back all the way to item 3, you process it again, you get to this, and then you check that condition. If it is the condition the result you want is not attained, you move back. And in so doing, we say you are within a loop. A flowchart representation will be this. We flow to item 3, we enter into a loop, and then we jump to item 3. So look at the flow, the logic, the flow line. It tells you to go back all the way to item 3. You move into the loop, you execute the jump statement, move all the way back to it. So that is a loop. Let's see how we can add this to our coconut milk algorithm. Okay, so I made some few changes here. They are in the red color, the red text. Now, when you look at step 2, if it is the last Sunday of the month, that is because in the definition we said that we prepare this every last Sunday in the month for our family get together. So if it is the last Sunday of the month, then what you are going to do is to get the ingredients and go to step 2A, that is from here, and then you go through step 2A through H. Otherwise, prepare your usual breakfast and go to step 3. Now see how the otherwise statement makes a jump from A to H and go all the way to step 3, which is clean up dishes and end of algorithm. In this, so because of the if condition here, the decision statement here, if it is Sunday, if the day is Sunday, it has made the step A through step H as part of the step 2 when the day is Sunday. If it is not Sunday, that if it is not the last Sunday of the month, you jump this whole process. You go to a different statement. That is the step 3. Let's look at the step 2E. That is the next thing that's the next changes that we have in there. It says to get maximum liquid, repeat step D, else discard the coconut. Now let's see what step D says. It says strain it through cheesecloth or sieve. Then you move to step E to get maximum liquid, repeat step D. So you're actually, sieving or squeezing the coconut until you get a lot of liquid out of it. If you have the maximum liquid, then you will continue with the F. So this E is a looping statement which makes you repeat step D until you attain a condition which is getting maximum liquid. All right. If you actually do this, you are going to get coconut milk. If you do this, you are going to get coconut milk. Remember, I told you that I got this from foodviva.com. They have a lot of recipes there, and I took this to design the algorithm. From what we have discussed, you realize that in designing an algorithm, there are 3 main things that we've talked about. You are always going to sequence set of instructions. You may make decision and change the path or the direction of the flow to continue on a different path depending on the output of the condition. And sometimes you will need to repeat certain set of instructions until you attain a certain result. So we term this to be the 3 pillars of algorithm design. Okay, thus the theory of algorithmic flow boils down to understanding just these 3 things. There are many ways of expressing these 3 things in a computer language like C++ or Java, but always remember that it all boils down to just sequencing, branching, and looping. These are the 3 pillars of algorithmic design. Also remember, if you are given an algorithm is given to 2 programmers. Okay, when they finish writing the program, when you input the same data to these 2 different programs, you are going to get the exact output.